Hello, hello. My name is Tecumseh McMullen, and this is the Quadtree node. Uh, Here's the README file explaining the Quadtree data structure and how using log n works better than just in. Because it's on a three-dimensional plane, it only checks two-dimensionally first and then only goes three-dimensionally if it's in the right area. Let's go to Quadtree. The insert function, subdivide function. So the way subdivide works is it takes the point. If it has another point in the area, it adds it to a sectional grid, giving it a north, northwest, northeast. It gives it the corners, and then it creates like another grid within the grid. That is how the subdivide works. As you can see here, it just this one it divides by 2, and then the insert. Where is it? Oh, it's right here. It If the boundary is outside of the plane, it just doesn't put it in. If the And then the points, if it's not divided yet and it's not on there, it just places it. But if it is on there, then it will divide, right? It'll subdivide it, and I put it to insert into children to make it a little easier for the subdivisions. So it's a child for each of the points. Again, a little bit easier there. Um, and then the find nearest algorithm using the Quadtree system. It just starts off with the main points, which is the the where it's going. What is that called? The priority distance, which the query point. Yeah, it starts off with the query point, checks that, checks its subdivisions, and then it prunes outwards, creating its branches in the 2D field. And then if it's in the right thing, then it'll uh, check those three-dimensional things. And then for the test, whoop, I broke something already. Ah, accidentally hit a button. There we go. So the query point, which it checked first, and then the entrance showed distance, showed the brute force is the exact same. They have random numbers, same. So it's working as intended. Thank you. Bye.